Hi, I'm Tom Cook, Sales Manager of Southwestern Controls and Fluid Solutions. I would like to share with you today some aspects of hydraulic and lubrication filtration in aerospace and industrial systems. There's a lot of variations in contaminants. Not all contaminants are equal. I want to consider some of the various variables in contamination. If you're a gardener, sometimes you define a weed as anything that's not supposed to be there. And in contaminants, contaminant is anything in the fluid that's not supposed to be there. It can be particulate of dirt, air, water, waxes, and other fluids. Now, I have often in my career referred to contaminants as liquid sandpaper that are operating under pressure. They're not just sandpaper that are attacking the clearances of critical components, but they're powered sandpaper in hydraulics that they might have 1,500 or 3,000 PSI behind them. When doing that, I might give the impression that all contaminants are solid abrasive particles, and there are solid abrasive particles, but that doesn't tell the whole story. I might ask a person to look at this microphoto and tell me how many kinds of contaminants they see in this system. And typically people look at them and go, oh, there's 3 to 5 different types of contaminants. However, the reality is that this contaminant is basically one type of chemical reaction. It's a transformational gel. The reason it looks different is because as it's worked hardened through the hydraulic system, it changes colors and becomes a solid. These types of transformational gels that form in hydraulic and lubrication systems are transformational, and they change as the system goes on. They typically are involved with water coming into contact with one of the lubricant's additives. And this chart right here shows the effect of water on bearing life. Sometimes I get asked the question, will your very fine filtration take out my additives? Typically additives are 1/4 micron and smaller. And per se, our filters, even a 1 micron, will not take out 1/4 micron and smaller particles. But you have to consider that precipitates form, and that is that you have small additives that combine into a molecular configuration of wax, where it forms under a microscope. You can see something that almost looks like grape clusters, where you have a combination of carbonate, water, and oil film. So when looking at these slimes and gels and these transformational gels that work hardened into solid contaminants, you got to get right to the root and consider how water enters systems. And it does that in a variety of ways. It can be in storage, it can be retraction from pulling in wetted cylinder rods, it can be a worn cylinder actuator seals, it can be leakage of heat exchangers, condensation, water vapor, reservoir cover, filler breathers. All those are potential sources of water getting into a system. Then you have to consider the chemical transformation, which results either in free water, which is visibly separated, emulsified water that's shaken up, or dissolved water, which is invisible. One practical tool, if you're concerned about water, it shows up at lower temperatures better. So get an oil sample, put it in the refrigerator overnight. If it's cloudy, you may have a problem. Southwestern Controls Fluid Solutions offers an optional integral hydrophilic component within the filter media to be able to tackle this problem. One of the initial studies we did with water ingression, we found that we could take out water, but then once we removed the filter element, we found that there was a slight jump in the water level, and then when we started again, we went back down. And what we found, it was extremely important as to how you handled this particular water saturated element and how you flushed the component in between filter changes. This is an example of where there was a 4,000 gallon reservoir, and with a dry pack component, we were able to go from 14,000 parts per million of water down to 11, down to 2,800, down to 482 parts per million in about 4 days. Here's some other raw data from a Houston major chemical company where we use this water removal technology, and it was both measured by the customer and buy Southwestern Controls fluid solution. And you can see the rapid development of going from 770 parts per million down to 50 parts per million within 8 days, actually getting down to a tolerable 82 parts per million within about 21 hours. Lab tests revealed that we could get from 5,000 parts per million down to 700 parts per million in a single pass. We were surprised when we saw the water holding capabilities of these dry pack elements. And what we found, the reason that we were able to grab so much water is that it actually accumulated on the outside of the filter element, much greater than the dirt holding capacity. At Southwestern Controls Fluid Solution, we're experienced and capable to handle a wide variety of contamination system and hydraulic and lubrication fluids. Call us to give us an opportunity to work with you on your issues. Contamination variation can be very complex. You can attack the problem through a detailed oil analysis. Let us know how we might be able to assist. Thank you for your attention.